Last video, that was just us getting used to the idea of how to write uh, inequalities that represent scenarios, right? We didn't talk about graphing or analyzing solutions or anything like that. Here's a word problem that we are going to do that. So it says you need at least 3 pounds of fruit to make muffins. Blueberries cost $4 per pound. Strawberries cost $3 per pound, and you can spend at most $21 on fruit. So if you saw the last video, I honestly think that you should pause this for a second and just grab a pencil and paper and just try to see if you can create the system of inequalities on your own, being that you saw the previous videos or that you know how to do that. Okay, so that's the first step, and then compare it to my answer. So pause it now and try it, and I'm going to continue, and you can just unpause it. So it says when we're doing this, do you remember that we always want to identify all our units? So let's just go ahead and just write down some stuff. It says you need at least 3 pounds, so we're going to annotate this. Okay, we need at least 3 pounds. Okay, blueberries cost $4 per pound, so blueberries. Oops, that's not how you spell blueberries. Berries cost $4 a pound. We have that strawberries, they cost $3 per pound. Okay, LB means pound. And then it says you can spend at most, right, $21. Okay, so it took a long time to write down strawberries and blueberries. So what we're going to do is we're actually going to put over here on this side, I'm going to make a let statement. Okay, so I'm going to say let x equal to, now we can't just say blueberries. It has to be very specific. Like, is it the cost of blueberries? Is it the size of the blueberries? Like, what are we really looking for? All right, and it says that we need at least 3 pounds of fruit. And then we have, so if you need 3 pounds of fruit to go make a muffin, that means that you have to physically go in the supermarket and buy blueberries. And blueberries come in pounds, and there's little tiny containers, and they cost $4 per pound. So we need, this is the number of pounds. Okay, the number of pounds of blueberries. And then similarly, let y equal the number of pounds, LBS means pounds, of strawberries. Okay, so from there we can make our inequality. What is the totals that we're looking for? Totals is, let's see, I see right here at most $21. Okay, that looks good. And he needs at least 3 pounds. That's actually a total. That's the total amount of pounds that he needs to make his muffins. So I'm gonna come over here and we're gonna start with this amount first. Okay, I'm gonna write our total here. So how do you represent at most $21? At most means the maximum that he can spend is $21. He cannot spend more than 21. He doesn't need to spend exactly 21. So he can spend less than $21 or exactly 21, but not more. So that's a less than or equal to sign. Less than or equal to 21. Okay. And this is going to be our total, right? So all the totals will go right down here. Now, what is this total made up of, right? This is money. So if this is $21 on money, everything here must be about money. So we can find that right here at blueberries. So blueberries was $4, okay, a pound. And if I just write a 4, that just means that I bought a pound. But I don't know how much I'm going to buy. So you're going to use 4x. Okay, x is the number of pounds. So let's say that if this x was a 1, that means I bought 1 pound of strawberry for $4. If this was a 2, I bought 2 pounds of strawberries for $4 each. That's $8. Okay, so that's what the x represents. I'm changing the number of pounds, but I'm paying a certain price for each of those pounds, plus the number of pounds of strawberries, right? But I need to put a price that's associated with that, so it's 3y. So $3 for every pound of strawberries that I buy. So this tells you the total amount that you spend buying a specific amount of blueberries. This tells you the total amount that you spend buying or purchasing a certain amount of strawberries, but when you add them together, those totals must be less than or equal to 21. Then you have the other total now where you have at least 3 pounds. Okay, at least means if I'm making a muffin, I need to have a specific minimum amount of ingredients. I can have more, but I can't have less than what I need to make it. So I can have more than, greater than, or equal to 3 pounds. Okay, now if the 3 represents the total on the left hand side, we must also have something that represents that. So what is 3 pounds made up of? Like, what are we getting that, or what are we weighing in pounds to get to that 3? Okay, well, we're talking about the number of pounds of blueberries and the number of pounds of strawberries. Okay, there's no number that's needed there because this represents the number of pounds of blueberries. If I add that to the number of pounds of strawberries, in total we should have at least 3 or more. Okay, so this is money, this is pounds. Now it says identify and interpret a solution to the system. Okay, so in order to do that, we need to actually graph this. So what I'm going to do is on the right hand side here, we're going to graph 4x plus 3y is less than or equal to 21. In order to graph, we know that we have to have it in slope-intercept form. So slope-intercept form means the y has to be by itself. So we're going to go ahead and just start by subtracting 4x on both sides. And if we come down, we get 3y is less than or equal to. Now, we always want to put the mx first, or in this case, the negative 4x, and then add the 21. Then finally, we will divide each term by 3, and we get that y is going to be less than or equal to negative 4 over 3x. Okay, we'll leave this as a fraction. Why? Because it's a slope, and slope should always be written as a fraction when you're graphing. Plus 7 makes it easier to graph. So that's going to be the first one. Okay, then the second equation. Okay, we'll do them both at one time. So we have x plus y is greater than or equal to 3. Same idea. We're going to subtract x on both sides because we want to get the y by itself. And we get that y, right, this comes straight down, is greater than or equal to negative x plus 3. Right? And this will be the other equation of a graph. So we'll start graphing the first one. We'll do that in blue. Okay, so we start at 7. So 1, 2, 3, 4, 5, 6, 7 right here is where we're starting. And this says we're going down 4. Remember, the negative means you're going down, but the number on the bottom, you always move to the right. Okay, so we're going down 4, right 3. Down 4, right 3. Okay, perfect, like this. And then if you have the solid line, right, this is a less than or equal to sign, so we're actually going to be using a solid line here. Let me go ahead and make a solid line real quick, just like that. Okay, maybe extend that a little bit, or just draw another one. Okay, all right, that works then. And let's see, the other one now we'll do in red. So we have, it was at positive 3, so we're going to start positive 3, and we're going to be going down 1, right? There's really a 1 there, and you can also put this over 1, make a fraction. So down 1, right 1, down 1, right 1, down right 1. Okay, and we're going to then draw another solid line because it's a less than or equal to, I'm sorry, it's a greater than or equal to sign. So we're going to draw a nice solid line there. Maybe I can get it in red. Awesome. So that looks like this. Okay, not like that. And the final thing now is that we have to shade. Okay, but before we shade, I just want to talk about something really quickly. Do you notice that this is really not a whole graph? Like, there's an emphasis on this quadrant versus this side or this piece or this piece. Why do you think that is? Well, it's because you see here, let x equal the number of pounds of blueberries. Right here, this is the number of pounds of blueberries. Okay, so everything down here is blueberries, and right similarly over here this would be strawberries. Okay, oh, I'm killing it at writing sideways right now. So is it possible, right, if we were in this quadrant here, is it possible to have a negative number of blueberries? Absolutely not. Is it possible to have a negative number of strawberries down here? No, it's not. It's not possible for you to go in a store and buy a negative number of strawberries. So that's why we actually don't need these quadrants. We're just going to work with the positive numbers. So I hope that helps. It looks like my camera just froze a little bit. That's okay. All right, so over here we have a less than sign. Now remember that the graph that we made for this was in blue. So less than, I'm shading below, okay? And we'll shade all the way down so we can really see like what's going on here. Shade all the way down. And then in red, okay, we're gonna do anything greater than. So we'll do also another emphasis here. That's okay. Because what we're looking for is we're looking for the area, we're looking for that area where there is shading, overlap. Sorry, I'm trying to choose the right thing here. Okay, so like literally anything within these parts right here, okay, within this piece right here, okay, we're not looking at anything negative, just positives. Anything there is going to be what we call a solution. All right. Now, if we were to go back, it says identify and interpret a solution to the system. Okay, that's anything where there's overlap. You see what all of this overlap is? So you can choose like a nice number that's right in the middle. Okay, if you have to choose. This is 2 comma 2. So 2 comma 2, okay, means, remember this is x comma y. This means 2 pounds of blueberries and 2 pounds of strawberries. Okay, and that means that if I go and I buy that, that's valid. And part C now says use your graph to determine whether you can buy 4 pounds of blueberries and 1 pound of strawberries. Remember, down here is blueberries, on the side here is strawberries. So if we go and we check that out, okay, so let's go and check that out. 4 comma 1 is here. Okay, is this in the shaded area? It looks like it is. So I'm going to go ahead and say 4 comma 1, okay, 4 being the number of blueberries, which is the x-axis, 1 being strawberries, that's this axis here, is a good combination to buy. All right, and what I also just want to do really quickly, because I know I'm kind of like totally dragging this out right now, is I want to just show you why it is possible. So I'm going to go ahead and erase this piece here. And what I'm going to do is I'm going to write down what the 2 initial equations were that we made. So we had made 4x plus 3y is less than or equal to 21. And then we also made x plus y is greater than or equal to 3. Now these are the ones that we made. If you remember from previous, the only way that we know if something is a solution is if both of these are true. So I'm going to use this fact here, 4 comma 1. Okay, so 4 comma 1 is what we're going to input. Every time I see an x, I replace this. So this is going right there, and this is going right there. So 4 times 4 plus 3 times 1 has to be less than or equal to 21. So 21. Is it true that 16 plus 3 is less than or equal to 21? Well, 19 is definitely less than or equal to 21. That means that if he went and he bought 4 pounds of blueberries for $4, he spent $16 on the blueberries. If you bought 1 pound of strawberries for $3, he spent $3 on strawberries for a total of $19, which is less than what he can spend. If he bought 4 blueberries, right, 4 pounds, and 1 pound of strawberry, again, I'm just substituting these coordinates here. Is that greater than 3? Well, 5 is definitely greater than or equal to 3. So it shows that it is possible for him to go to the groceries and buy multiple pounds of fruit, right? So he can buy 4 pounds of blueberries, 1 pound of strawberry, be more than 3 pounds altogether, and still spend less than 21. And this is the area of combinations that can happen. Right? It can be 2, 2. He can buy 4 of this, 1 of that. He can buy 2 of this, 2 of that, 3 of that, 2 of that. It depends, as long as it's inside here. And that is what the main purpose of these types of problems are. So I hope that this helped to clarify a couple of things. I am planning to do about 2 or 3 examples. So please watch them if you think that you still need more help.